Okay, we'll start talking this week about tropical weather. You might want to pay a little attention to this with Sandy being the main topic of your signature project coming up here. So, what do we know about tropical weather? What are some of the conditions required for the development of tropical cyclones? These are very different systems and they're very different structures than what we talked about with extratropical cyclones. So, tropical weather typically forms between 23.5 degrees north, 23.5 degrees south. Why is that? Well, basically, the sun's overhead all at some point, and there never a frontal passage there. The air masses are pretty uniformly warm, humid. Uh, there's not a lot of temperature variation. The diurnal temperature variation, in fact, is greater than the monthly means differences. That's a big difference than what we live with in the mid latitudes where we are. Sometimes there's thunderstorms that set up in clusters down there. They can become quite intense. And think about it, along the intertropical convergence zone, there's convergence right in that word. There are a lot of thunderstorm activities that develop and weak little systems moving along there, which tend to enhance precipitation, and it makes that the rainy season when the intertropical convergence zone is over that area. We use what we call streamline analysis instead of isobars pressure analysis. Why we do that is it can pick out convergence and divergence areas very well in the tropics, that you're not getting a lot of pressure change there. You don't have very intense lows typically. By just drawing the winds, taking a line and drawing right along with the wind flow, you can actually see where the lines converge because of the winds converging there or diverge. Hurricanes are the most intense features you find in the tropics. And there's major differences between a hurricane and an extratropical system. Extratropical systems get more intense with height. They have major temperature contrast across them. Hurricanes, uniformly the same temperature across. They get weaker with height. And hurricanes typically are in much smaller systems, where extratropical cyclones can cover thousands or more miles sometimes. Hurricanes have been as small as only 100 miles or maybe even 75 miles across. So, scale differences as well. In the hurricane, there's an eye. You don't typically have an eye in an extratropical cyclone. We're going to talk about why that occurs here. And there's an eye wall around the hurricane where the strongest winds occur. They don't occur at the lowest pressure, which is in the center of the eye. They actually occur in the eye wall just a little bit from it. That is very different than an extratropical cyclone where the winds can tend to be the strongest near the center of the storm. So what happens? Well, in a hurricane, you have winds spiraling in. You have very strong convergence, and they're rotating. And they gradually are going up, up, and up all around. And what happens is, in the very center, all that air has gone up, but now they're sinking. There's an extratropical cyclone that literally forms on top of a hurricane. That extratropical cyclone actually pushes the air down, but it has air moving out as well, away from the storm. So by doing that, it allows the air to continue to go up very strongly around the eye, but it actually descends in the center of the eye. You'll see these bands too on extratropical cyclones. Those are areas of convergence that form thunderstorms or heavy showers, and they tend to literally look like they're in bands. One of the conditions necessary for hurricanes, you want warm waters. What does that mean? Well, they got to be greater than 80 degrees to a depth of at least 150 feet. So in other words, if you had a cool ocean temperature, you're not going to get a lot of hurricanes forming. If you have a very hot ocean temperature, you have better chances. Another thing is they need Coriolis effect. And one of the reasons they need the Coriolis effect is they got to get that rotation, which can't occur. Here is just an image of the warm circulations. Just last week, there was a system that moved up the east coast of the United States and hit New York, New Jersey, and that area. It weakened as it got north of the Gulf Stream. You'll notice here there's an image of cold water that occurs just north of the Gulf Stream. Once these storms get away from that 80-degree water temperatures, they tend to weaken. So that's what happened with this storm. And because of the Coriolis effect, they can't form within 5 degrees of the equator. That's why places like Curacao and all down at the very lowest parts, islands down by Venezuela and stuff, don't get tropical systems very often because they're not have enough Coriolis effect. You need weak winds aloft too, because you want these thunderstorms to organize literally vertically. They want to grow up. They don't need wind shear like we do in thunderstorms over the United States to cause severe weather. You want these thunderstorms to keep growing up straight, and wind shear would tend to tear them apart. So that's why during El Nino we get fairly strong winds in the tropics, and you wind up getting less hurricanes those years. On average, there are more named hurricanes and tropical storms in the Pacific than there are in the Atlantic. However, tropical systems move from east to west. So the ones that form off our west coast or off of Mexico on the western side in the Pacific tend to move on out into the Pacific and don't bother anybody. However, in the east, the Atlantic ones are moving towards the United States. That's where we're getting our strikes from. And every once in a while, the Pacific storms do come up and threaten the Hawaiian Islands. However, they have trade winds that actually cause an inversion, which means temperatures are warming with height at about 20,000 feet, 15 to 20,000 feet up. And that diminishes the hurricanes coming into the Pacific Islands of Hawaii. And here you can see where they typically, the tracks you see. And here's the peak season. Guess what? We're right in the middle of it right now for the United States. Most hurricanes would typically be forming right about now. And one of the interesting things about hurricanes is where they typically form depending on the month of the year. The warmest waters during June are over the Caribbean. That's where they begin to form. The ocean, the Atlantic, is beginning to heat up in July and August. And disturbances are coming off of Africa that may form further out. September, water is the warmest everywhere. Noticed in October a lot along the Gulf Stream because it stays warm in the Caribbean. And finally in November, basically right along the Gulf Stream is the only place that's warm enough. There are waves called easterly waves that move across. Some of these actually are what trigger tropical cyclones. And interestingly, an easterly wave that's moving across, you have divergence ahead of it, so you have very little thunderstorm activity or even clouds out ahead of it. Then once it passes you, you wind up having convergence. So there is something else called a sub-Saharan air layer. What happens is this air layer develops over the Sahara Desert, literally, and it's a mass of dry, dusty, very stable air. It's been heated from below, but it's so dry, it just inhibits any convection that's going. So when it moves across, and it moves all the way into the southern part of the United States or eastern United States sometimes, and will bring dust with it. It actually can reduce visibilities in parts of Florida and along the east coast of the United States and in the islands to our south. So hurricanes start, air pressure begins to fall, and the circulation develops. It needs a lot of moisture. So if there's dry air and a Saharan air layer is dry, that's going to can kind of impact these thunderstorms that develop. They're not going to get going as much. And if you looked at the system that have developed this year, a lot of them had some dry air around them, so they never really got going. They get a certain intensity, but they just had too much dry air, and some of them had wind shear that kind of impacted them. Here's the criteria for naming them. Maximum sustained winds must reach at least 23 miles an hour for tropical depressions, 39 miles per hour for tropical storm, 74 miles per hour or hurricane. The hazards from a hurricane are the storm surge and rain. They're the two biggest causes of deaths in the United States directly attributed to these. So, if you have a hurricane, it's formed over the tropics. It's forming in a very warm, extremely moist air mass. So that means it's going to be moving along, bringing that air mass with it. So it is transporting a tremendous amount of warm, very humid air. Great for causing intense precipitation. One of the worst rainfall events in the history of the eastern United States occurred when Camille, several days after it had come in and destroyed the Gulf Coast, that same system moved up into the southwestern part of Virginia. In one day, it dumped over 30 inches of rain on some mountains up there. Literally, whole mountainsides collapsed, and hundreds of people died. By that time, it had been a tropical depression for several days. Nobody even thought it was going to intensify again. It didn't intensify. It just dropped rain. Here you can see Harvey's tremendous rainfall over Houston area where it basically almost stood still. So the winds are caused by pressure gradient. We learned that before. And the stronger the winds, they increase with the square of the wind speed. It increases the force on a building. So if the wind speed's 50 miles an hour, it would square that wind speed at 100 miles an hour every time it went up. So it really, the faster the wind, the greater the force by a lot. And there even can be little whirlwinds sometimes in the center of the storms. And winds will diminish after landfall. Friction comes in, slows it down. Oh yeah, it's lost its source of energy, the warm ocean water. So all these are gradually going to reduce it. However, it can still produce tornadoes. And storm surge. Storm surge is just water that is driven into land by all that wind blowing. So if you have a storm, we'll say it's coming into southern Florida, in the Miami area, and it's moving from the east to the west. North of that storm, the winds are going to be from the east. Remember, they're counterclockwise. That east flow is going to cause the water to pile up on the east coast of Florida, north of the storm. So you wind up with the greatest storm surge there. Now, south of the storm, the winds are coming from the west. So you actually push the water away. Your storm surge could be none, even may have a lower than normal tide. One other thing with the storm surge, if that storm surge occurs at the time of high tide, many times high tide is 5 to 6 feet above low tide. So that adds 5 to 6 feet of water that would occur. Now, if that same storm had hit at low tide, it may not have caused near the damage. Something you will see when you discover about Sandy. And here you can see the example. When you raise the sea level height due to the storm surge coming in, you wind up literally destroying the buildings. From the waves are on top of that as well. And storm surges can easily, in some locations in the United States, exceed 20 feet. And this is just an example of the damage from them. And you can see literally, here's one picture, After hurricane came in with the storm surge, not much left over a large part of that area. These are some of the maximum storm surges. I mentioned Camille as far as rain, but its storm surge was 23 feet when it came inland. Sandy had 12 feet. So, and here we talked about it. They can be forecasted. We use something called slosh to forecast them, which gives you an idea of how high the storm surge will be. And we'd issue storm surge warnings now with the Weather Service. Some of the trends actually have shown challenges trying to understand what the hurricane activity is going to be like in the future. And one of the things we use is the Atlantic multi-decadal oscillation. What it is temperature change in the Atlantic. Notice the 1970s into the 80s, water temperatures were well below normal, and that well below normal translated into a lot less hurricanes. As a matter of fact, I went to college between 1970 and 74. I was at Florida State at that time. And one of the things we as meteorologists wanted to do was experience a hurricane. Guess what? During those 4 years, we didn't have a single hurricane that came in during the whole time we were in college, anywhere within 500 miles of us. Matter of fact, there was almost no hurricanes during that time. El Nino is another factor. It can cause intensification of wind fields across the tropics. And here is just an example of what we expect to happen with temperatures warm a couple degrees. We're not expecting more hurricanes, but what we are expecting is more intense ones maybe, and more rainfall. Think about it. Warmer temperatures, more water the air can hold. And there's a lot of people that live along the coast. Evacuations can take days, literally, along the east coast of the United States. Here in Virginia Beach area, if we had a Category 4 hurricane coming towards us, we need 3 days to evacuate the amount of population that lives in the potential to be covered with that surge. Barrier islands can protect us, and they do exist along the east coast of the United States and in the Gulf of Mexico. So now let's just take a look quickly here. This is what's going on today, and you can see here in the Caribbean Ocean is a beginning of a tropical cyclone. It hasn't developed yet, but it is expected to. As a matter of fact, the Hurricane Center is giving it a 90% chance. And they're moving it in somewhere in the Gulf Coast later on here. So that will be something to see how that works. And I wanted to give you a Caribbean, just look down there at that sector. We'll do an animation of that area. And give you a professional, will somewhat look at the storm here. Here is that low, and you can see the clouds rotating here. Thunderstorms to the north, thunderstorms to the south, not a lot to the west yet. One of the things they're going to look for is they want to see these thunderstorms concentrated in an area around the low, and they want to make sure this low is completely closed off, that if you were able to trace a wind field, you would actually see a full counterclockwise circulation, just not part of it. So, but there is a lot of moisture there. You don't see the dry air. It looks like to the west there's some, but there is a tremendous amount of moisture in that area and stuff. So there is some good potential for this storm to develop with time. So let me know if you have any questions on this.